No, you know what? I think I just have to go back and review stuff. It's easier for me, like if I go back and reread and I think about it more.
Yeah, that's me too. I've had to read, like, whenever I do the readings from the online book, I read it like 3 times before I get it.
Yeah, because sometimes the lessons that come on like the little visual thing, the videos, they don't make sense.
Yeah, I know what you mean. Okay, then.
So let me just open up right now on the computer. Want me to start making that sauce or something? You can. Cut the pickle smaller. Okay, I'll do this while I'm sorry, he's trying to make dinner.
It's okay, you're good.
We had piano late today, and
All right.
okay.
Um, I guess since I'm on my laptop, I'll just screen share and then we can take the quiz together if you want.
Okay.
Okay.
I am there.
All right. Let me see.
Diego, can you get me a pencil? Okay, I'm there.
All right. Can you see my screen?
Yeah.
Awesome. Okay.
Okay.
So the first two are true. All
Uh-huh.
right. So in the reading, it said that the total area under the density curve, which is like
Uh-huh.
the curve that goes over the histogram, I'm pretty sure it has to equal 1. I
Yeah.
wrote it down.
I have the
Yeah, it's 1.
you can't have my phone right now, honey. So it says under number 4 says under certain circumstances, the density curve can drop below the x-axis.
I think that's false because like under the reading with there's like those two basic properties, and number one was it has to be the area is under, I mean the area is equal to 1, and the
Uh-huh.
second part says it's always on or above the
Yeah,
x-axis.
it can't be a negative.
Yeah.
So
All right. Number
that's
5,
false.
a normal density, oh whoops, I put false. A normal density curve is symmetric. I'm pretty sure that's true. I wrote that down. Hold on, let me see. Yeah, that one's true.
Yep.
Number 5.
It says use the following image to answer questions 6 and 7. So it has a bell-shaped curve. It says for 6, it says which of the following elements of the figure represent the z-score on this image? A, B, or C? Or none of these represent?
I think it's C because A is like the percentiles, like
Yeah,
the and B is like the empty, like
the
not what we're
empty,
even
yeah,
counting.
it's outside of, yeah. So yeah,
Yeah. All right, and then 7 says, which of the following elements of the figures represents the probability that the z-score will be greater than 1? And that one would be B
B.
because it's above the z-score. Yeah.
Okay, so 8 says according to the 68, 95, 97.7 rule, what portion of the data from a bell-shaped distribution will be within one standard deviation of the mean?
I think that's 68%.
Hold on.
I think, because you know how in the reading it like drew the bell curve for us,
Uh-huh.
and then it showed like the middle part was 68%. So I think that 68% is one standard deviation on either side.
Huh.
Does that make sense?
No. Let me go to
Okay.
the book.
Let
Um,
me just pull up the book.
I don't see that on my notes.
Here, I'll find it in the reading for you really quick. Hold on. Oh, that's not what I wanted.
30. Just a smidge. Yeah, like a teaspoon. And then, yeah, the ratio to mayo is an even amount of ketchup to where it looks kind of like a pink. They're trying to recreate the the In-N-Out sauce.
Oh, that's so cute. That sauce is good though.
Yeah.
Okay. Almost to the book. The internet is running so slow here.
So normal. Okay, parts 1. Okay, so yeah, you're right. 68% is one degree either way. Yeah.
Okay. All right, just had to make sure. All right, so we'll write 68%. Oh, we can't write a percent.
How many questions are there? Oh, 18. Wow.
Yeah,
seems like there's more. It says suppose that the z number 9. A little bit more. Yeah. It says suppose that the z-score comes from a standard normal distribution. Use the normal applet to answer this question. What proportions of the values from this random variable will be between -1 and 1? Give your answer as a decimal accurate to the 3 decimal place. Therefore, if your answer is or was 0.389184, you would enter 0.389.
Okay, so when we like pull up that normal applet thing, you just write 1 and -1 on the z-scores. And then when you like enter those in there, it should, that the area at the top should be the answer. So 0.683 rounded.
So
put that in. So it should be
0.683.
Yeah. Could be. We'll see.
I know.
All right, number 10. Suppose that z-scores come from a standard normal distribution. Use the normal applet to answer this question. What portion of the values from this random variable will be between -2 and 2? So that one we do the same thing. We just put in 2 instead, which is 0.955.
Okay.
0.955.
Do I need some mustard?
Yes, you do.
Whoops.
Okay. So 11 would just distance it out another degree out. It says suppose that the z-score comes from a standard normal distribution. Use the normal applet to answer the question. What portions of the value from this random variable will be between -3 and 3? Give your answer in decimals.
So that one would be 0.997.
0.997. Okay.
And then the answer to 12, it says just like, what do you observe from your answers for 9, 10, and 11? And I think it's the first answer. They match the 68, 95, 99.7 rule, because all of our answers, like 9 is 68, 10 is 95, 11 is 99.7. Yeah.
Yeah.
And that makes sense because like 68 is 1 standard deviation. So number 9 says like use 1 distance out.
Yeah. But what am I going to use this all for, you know?
Yeah, it's true. All right, almost there.
It says the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram of body weight. Okay. It says the population mean protein requirement for an adult is 0.66. I'm assuming that's grams.
I don't know.
It's gotta be. And then P would be times kilograms -1, D -1. The population standard deviation is I No. No. You don't need to put salt. 0.07 grams times the kilograms minus the 1. Doesn't the, oh, that's -2. Use this information to answer 14 to 11. Okay.
Okay, so
we
the
just
first part, what?
We kind of just plug in the numbers, right?
We have to use, for this part, for the very first part, we have to use the z-score equation, which is like z equals x minus the mean divided by the standard deviation.
Oh.
So we would take, the number we're trying to get is 0.6. So we do 0.6, and then you do minus the mean, which they said is 0.66. So minus 0.66, and that equals negative 0.06. And then you divide that by the standard deviation, which is 0.07. And then you get some negative number. And then that negative number that you get is the z-score, but you still have to find what's less than that. So you have to go to that normal applet thing, and you go to the bottom box on the left, and you type in like the answer you get, which is negative 0.857. And you're trying to get less than
0.66.
Yeah, so it should, I think it's 0.196, but I'm not really sure like where the less than goes, like where to highlight the less than thing. Is it just like the third on the left to highlight, or?
Let me open, see. What are you looking for? These but bigger. Oh, in there.
I think this is the answer because this is the z-score for the 0.6 that we were looking for. So if it has to be less than the 0.6, then that's what has to be highlighted. So I'm pretty sure that this is the answer.
0.196?
Yeah, I think. I don't know. Does that make sense?
Kind of.
So now the next thing is talk about the z-score. So the z-score is supposed variable.
I'm sorry, I turned that on trying to get to the book. Specific probabilities. Some vinegar and vinegar and pepper? Yes. Little pepper, right? Yeah, and very little vinegar, Diego. I think so.
Like, I'm pretty sure it is because like the z-score for 0.6 is the negative 0.857, which is what we have down here. And then when you enter that in, that's what you get. And that's like less than that right there.
Okay.
So I feel like that is right. I'm still kind of iffy on these problems.
Yeah, I haven't tried any of these problems. I was good up until the bell.
Yeah, that's what confuses me a little. I guess we can just go ahead and try that answer, 0.196. See how that goes.
Okay.
All right, number 14 says, what proportion of the population have a protein requirement that is more than 0.6? So
that would be above.
Yeah, so we just highlight the other two sections.
Yeah.
And that's 0.804.
0.804.
Okay.
But would it just be oh no, because it that's not the center, that's the far right, correct?
Okay, so this red line right here, I'm pretty sure is what 0.6 is. So anything that's above it is what we're looking for in this question. And the last question was anything below that line.
Okay.
So this line is the z-score for the 0.6 that we saw in the first problem. So.
You have a test that you have to study for, huh?
Yeah. but it's good we're almost
What class?
done. I'm taking a pre-calculus class.
Oh, and what's
So
what's your major?
a math major, so that's why.
It
But-
says that's
Yeah.
a lot of math. Okay, so number 15 says, what portion of the population have a protein requirement that is less than 0.70 g? Give your answer as a decimal accurate to 3 decimal place.
All right, so for this one, we have to redo the
Yeah, we have to
z
start
square.
from the beginning.
So it'd be 0.7 minus 0.66 divided by 0.07. So that gives us 0.5714. And since it's positive, it'll go into this box. So 0.5714. Okay, and then what did it ask for?
Oh, no,
Less than.
this is for less than.
All right. So I think that's it, because this is the z-score for the 0.7. And then if you're looking for less than, it's going to be these two sections. So I think that's the answer. 0.716. Okay, number 16 says, find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7. Hint.
The middle.
Yeah, I don't remember how to do it. Oh, so we would just...
It says, remember,
but it's different because...
because you know how if you're looking at that bell, you know how earlier we were looking at the -1 and positive 1, and we took the middle?
I think so, yeah.
It says, remember that it says hint. Remember that to find the area between two values, shaded to the left of each z-score to calculate and then subtract the smaller area from the larger area. Make sure your answer is positive. This is the probability that a random selected observation will lie between these two values.
Oh, so we just subtract our answer from 15 to our answer from 13.
Yeah.
So 0.716 minus 0.196 is 0.52. And make sure you put like a 0 at the end because she wants 3 decimal places.
At the end?
Yeah, 0.520.
Are you putting a 0 in front of that point? Because I am.
Oh, I usually try to. Okay. All right, 17. 2 more questions.
It says, find the 35th percentile for the protein requirement for adults.
So we would just say 35 or 30?
35.
So we would just put 0.35 to the top. And since it's a percentile, it's asking for how many people have that score or less or whatever.
Mm-hmm.
So it would just be 0.385. Wait, is that right? I feel like there's another step we need to... Oh, okay. So we have the z-score, which is 0.385, but we still have to solve for x in the z-score equation.
Okay.
So we know that the mean is 0.66 and the standard deviation is 0.07. So we have to take 0.385 and multiply it by the standard deviation, which is 0.07. And then we have to add the mean, which is 0.66. So that would make x, the value we're looking for, equal 0.687. Does that make sense?
Yeah, I'm calculating right now.
Tell me if you get that answer, 0.687.
Oh, it said error. 385. 335. Oops, sorry.
Oh, it's fine. Times 0.07.
Did you get 0.686?
Yeah, and then I rounded it up because there's a 9 after the 6. So I rounded it to 7.
Yeah.
All right. And then we do the same thing, but with 80%. So this would be, whoops. So the new z-score is 0.842. So then now we just have to find x again.
Okay.
Times 0.07 plus 0.66. Okay. I got 0.7189.
Okay, let me try to do, you multiply a lot faster than I do.
I have my calculator out. It's okay.
Let me see, 0.8 or 2 times 7.
Want me to get your calculator?
No, because it's on the phone.
I know, but
Yeah.
Okay. All right, then. Let's see how we did. I always worry. Oh, we got 95.
Oh, good. I'm good with that.
Let's see what it was. Oh, okay. Number 17 we got wrong.
Oh.
Okay, let's try that again then. I just want to know. 0.35. Whoops. All right, so less than z-score is 0.385 times 0.07.
For 18, I still haven't submitted it, but did you round that up to 718 or did you round up to 0.72?
I rounded it. It was the answer I got was 0.7189, and I just rounded it to 0.719.
719. Okay.
So I don't know why we got number 17 wrong. I just did it again, and I still got the same answer.
It follows the same premise to the one we did for 18.
Yeah, that's weird. I'll email her and ask, but it might be just because we weren't supposed to round or something like that. I don't know.
Oh, darn, I didn't put the trues to 1 and 2, and I got a 75.
Oh, did you forget? Oh,
I'll
no.
email her and tell her.
All right, then. I think we're done. When do you want to meet next?
We have to do it by Monday of next week, right?
Let me look at the schedule real quick. I can't remember.
that's still 3 though.
Yeah.
RV.
Yeah, but I'm gonna. I totally skipped those 2. And I said, yeah, let's just start with 3.
It's okay.
I'll email
All
her
right.
and tell her.
Lesson 6 is due on Tuesday.
So by Monday?
Yeah, we can meet we can meet Saturday sometime after conference sessions are over.
Oh, yeah, that's true.
Or we can meet Monday night, like any time on Monday night works for me.
Monday night works good for me too. Saturday night works well, so it's up to you.
Let's do Monday night because so I can get the rest of my homework done on Saturday night.
Okay.
And whatever time works after about 4:30 Mountain Time.
Okay.
So I think that's like
3:30
Central.
So I get home from work on Monday at 5. So
Okay.
for me it works best like 6 and after.
Okay. Okay, we'll just email me on Hangouts and by Monday morning and just let me know what time for sure you're fine with and then we'll figure it out from there.
Okay. Thank you.
Yeah. All right. I will talk to you on Monday.
Okay.
Bye.
Bye.